The Chengdu J-20 Mighty Dragon, despite representing a significant stride in China's military aviation capabilities and embodying many characteristics of a fifth-generation stealth fighter, is subject to a range of discernible disadvantages in areas where its performance or design attributes present notable limitations, particularly when assessed against the backdrop of established benchmarks and the demanding operational realities of modern aerial warfare. These challenges span from fundamental propulsion issues to the nuanced complexities of stealth technology, mission versatility, and the maturity of its integrated systems. One of the most persistent and widely acknowledged shortcomings has revolved around its powerplant. For a considerable portion of its development and initial service life, the J-20 has been constrained by its reliance on Russian-designed Saturn Al-31F series engines or interim Chinese-developed WS-10 Taihang variants. These engines, while functional and providing adequate thrust for basic flight operations, were not originally conceived for the rigorous demands of a true fifth-generation platform aiming for peak kinematic performance. Specifically, they lack the advanced thrust-to-weight ratios and, crucially, the efficient supercruise capability, the ability to sustain supersonic flight without the use of fuel-inefficient afterburners, that are hallmarks of aircraft like the American F-22 Raptor with its Pratt & Whitney F-119 engines. This engine deficit directly translates into limitations in acceleration, rate of climb, sustained turn performance, and overall energy maneuverability, especially in high-altitude, high-speed engagements. While China's indigenous WS-15MA engine is intended to ultimately provide the J-20 with performance comparable to its Western counterparts, including robust supercruise, this program has faced protracted developmental challenges, including issues with reliability, component lifespan at extreme temperatures and pressures, and manufacturing consistency. Recent, though not officially confirmed, indications suggest some J-20 airframes might be flying with WS-15 prototypes or early production models, but the widespread, reliable integration of this advanced engine across the fleet remains an ongoing process, meaning many operational J-20s likely still operate with performance constraints imposed by older engine technology. Furthermore, the exhaust nozzle design on J-20s, equipped with Al-31F or WS-10 variants, is generally considered less optimized for stealth, lacking the sophisticated two-dimensional thrust vectoring and sawtooth-edged nozzles seen on the F-22, which contribute to reducing rear aspect radar and infrared signatures. This makes the J-20 potentially more vulnerable to detection and tracking from the rear. The effectiveness and comprehensiveness of the J-20's stealth characteristics also present areas of concern. While the aircraft clearly incorporates stealth-shaping features such as chined edges, blended wing body design, internal weapons bays, and diverterless supersonic inlets (DSIs), its relatively large airframe compared to the F-22 Raptor might inherently result in a larger baseline radar cross-section (RCS) that is more challenging to reduce across all frequencies and aspects. Of particular note are the forward canards. While these surfaces contribute significantly to the J-20's agility and lift, especially at low speeds and high angles of attack, they represent a compromise in stealth design. Canards, being moving control surfaces with their own leading edges, can create radar reflection spikes, particularly when deflected during maneuvers or from off-frontal aspects. The interaction of radar waves with the junctions between the canards and the fuselage can also be a source of increased RCS. The sophistication, durability, and all-weather performance of the radar-absorbent materials, RAM, and coatings used on the J-20 are also subject to scrutiny. The development and application of effective RAM is a highly specialized field, and achieving consistent performance and maintainability, especially under harsh operational conditions, is a significant challenge. There are questions about whether the Chinese RAM technology matches the maturity and broad-frequency effectiveness of materials used on American stealth aircraft, potentially leaving the J-20 more susceptible to detection by certain radar systems, including lower-frequency surveillance radars that are less affected by shaping optimized for X-band fire control radars. All-aspect stealth, meaning low observability from all directions, front, sides, rear, top, and bottom, is exceedingly difficult to achieve, and design choices like the canards and current engine nozzle design may limit the J-20's stealth effectiveness from aspects other than directly head-on. In terms of mission versatility, the J-20 appears to be primarily optimized as an air superiority fighter and long-range interceptor, designed to engage other aircraft and threaten high-value airborne assets. Its air-to-ground capabilities, while present, are considered less developed compared to true multirole fighters like the F-35. The internal weapons bays, While sizable and capable of carrying long-range air-to-air missiles like the PL-15 and potentially shorter-range missiles like the PL-10, may impose limitations on the quantity and types of larger air-to-surface munitions it can carry internally. While it can likely carry precision-guided bombs or missiles, its sensor suite, software, and pilot vehicle interface may not be as extensively optimized for complex strike missions in contested environments as those of dedicated multi-role platforms. The development of a two-seat variant, often designated J-20S, which has been observed, might be an attempt to address some of these limitations by adding a weapon systems officer to manage complex tasks, but this also adds weight, complexity, and potentially reduces some performance parameters. This specialization could limit its utility in scenarios requiring a single platform to perform a wide array of missions effectively. The sophistication of its avionics, particularly sensor fusion and network-centric capabilities, may not yet match the most advanced Western systems. While the J-20 is equipped with an active electronically scanned array (AESA) radar, an electro-optical targeting system (EOTS), and likely a distributed aperture system (DAS) providing 360-degree infrared coverage, the critical element is the seamless integration and fusion of data from all these sensors, as well as off-board sources, into a coherent and easily interpretable tactical picture for the pilot. This level of sensor fusion is extraordinarily complex to develop and perfect, and it is an area where aircraft like the F-35 have a significant lead due to longer development and extensive testing. Any deficiencies in the J-20's sensor fusion could increase pilot workload, reduce situational awareness in dense threat environments, and slow down decision-making. Similarly, its ability to securely and effectively network and share data with other Chinese air, ground, and naval assets to form a cohesive fighting force is a developing capability, and its maturity compared to established Western Link 16 or MADL multifunction advanced data link standards is uncertain. The effectiveness of its electronic warfare (EU) suite against the sophisticated radar and EU systems of potential adversaries is also a critical factor that is difficult to assess without operational data but remains an area of potential disparity. Operational range, while intended to be significant given its size and internal fuel capacity, could be hampered if sorties require extensive use of afterburners due to less efficient engines for sustained high-speed flight, thereby reducing effective combat radius without frequent aerial refueling. China's aerial refueling tanker fleet, though growing with aircraft like the Y-20U, is still less numerous and less experienced in supporting large-scale, long-range stealth operations compared to that of the United States, potentially limiting the J-20's power projection capabilities far from its home bases. A significant intangible disadvantage is the J-20's lack of real-world combat experience. Unlike aircraft such as the F-22 or F-35, which have been deployed in operational environments and, in some cases, seen combat, the J-20 has not yet been tested under the stresses and unpredictability of actual conflict. This means its theoretical capabilities, tactics, and system reliability in a true peer-level engagement are unproven. The pilot cadre, while gaining experience, is also still developing the deep expertise and mature doctrines associated with operating a fifth-generation stealth platform on a large scale, a process that takes many years of intensive training and realistic exercises. Maintenance and sustainability also pose challenges. Fifth-generation aircraft, with their complex systems and sensitive stealth coatings, are inherently maintenance-intensive and require specialized infrastructure, highly skilled ground crews, and robust logistical support chains. Ensuring high operational readiness rates and sustainable sortie generation, particularly during sustained operations or in austere environments, can be a significant burden. The durability of its stealth coatings and the ease of repair for battle damage or routine wear and tear will directly impact its availability and operational tempo. Finally, the aircraft's large size, while beneficial for range and internal payload, could be a disadvantage in terms of visual detection at closer ranges and potentially make it a slightly less agile platform in certain within visual range maneuvering scenarios compared to smaller, more aerodynamically nimble fighters, even with its advanced canard delta configuration. While designed for agility, the fundamental physics of a larger airframe cannot be entirely negated. These limitations collectively indicate that while the J-20 is a potent symbol of China's aerospace achievements and a credible threat, it is still a system with developmental areas that need maturation and refinement to overcome inherent disadvantages when compared to the most advanced and operationally proven fifth-generation fighters globally.